we were talking this, I guess. Yeah, so you have to add up the probabilities for each separate event, and then you have to subtract probability of both of them happening at once. And in some cases, it might look like that you just add up without subtracting anything, like here. But here, it's, how do I put it? Well, here it's such a way because probability of a die roll being less than 2 and more than 4 at the same time is 0. So you can't have a number which is more than 4 and less than 2 at the same time, right? Because well, your number will be either less than 2 or more than 4. There is no way it can be both at once. And being 0, subtracting 0 does not change anything, so it looks like, well, how do you put it? Like you didn't subtract that and probability, but in fact we did. So we added up those two, right? 2/6 plus 1/6, and then we subtracted 0. So that's the general rule. So this one for AND events is called multiplication rule, or the rule of multiplication if you want. And this one is called addition rule. There is a bit of difference. So multiplication rule just tells you you should multiply the probabilities when you have one and another. Addition rule tells you, yeah, you should just add up, but then you should subtract this one. Well, I'm not sure if I can put the picture here. Okay, so there is that shapes thing. Maybe we can use them. Yeah, one shape. Oh, it seems I scrolled too much. Okay, so one shape, another shape. I'm not sure whether it will work as I intend, but we will try. Bugger it. So, okay. No, it seems it won't behave the way I want it to. There's no. Okay, yeah, here it is. So you can see that there is that small area where they intersect, right? So, for example, let it be this way. So this part here, this circle, is all the even numbers. Ow. Yeah, okay, I better use the text tool for that instead of typing, trying to freehand. All the even numbers. It does not want to type. Well, okay. Let me just use that pen tool. And maybe I will just change the colors. So this here, I don't know why it's behaving in such a strange way, but okay. So this part, yeah, this part where you can see some kind of abstract painting is all the even numbers. This circle to the left. The circle to the right is all the numbers which are more than 4. And this part in between, this intersection, are the numbers which are even and more than 4 at the same time. And if you want to calculate the total of those, you take one circle. Maybe we can do it here. Yeah, I guess we can. So you take one circle, you add another circle, and you can see that the part, this part, which is the intersection of two circles, which I will try to outline here now, but probably I will fail. Okay, so this part is counted twice. First in this circle and then again in this circle, when in fact it's just one part, it's not two parts. And that's why we subtract it after we add those circles. And that's why we, let me clear the screen. Yeah, clear all drawings and close that tool. And that's why we subtract this thing, this part, because we counted it twice. We counted this 6 two times. And to bring it back to only 1 6, we subtract it one time. Well, all right. So that's it. Oh, and there's one more thing. So to be able to use multiplication rule, your events should be independent. Like the outcome of one event should not affect the outcome of another event. Here, they really are independent. So a number being even or odd does not in any way influence it being more than 4 or less than 4. There is nothing, absolutely nothing that makes the even number definitely be more than 4 or less than 4. So there is no influence, no interaction. Those two outcomes are independent of each other. And for independent outcomes, you can use the multiplication rule. Sometimes you have the events which are not independent. Well, maybe we go back to coins. So imagine you are tossing the coins again, but your coins are magnetic this time. So your coins are little magnets, and you toss first one, and then you throw the second one. And the way first one lands will influence the way the second one lands. Because they are magnets and they tend to attract opposite poles together, and these similar poles will try to what do you call it, repel from each other. So if first magnet lands south pole up, then most probably the second one will land south pole down. So the outcome of first throw will change the outcome of will change the probabilities for the outcome of the second throw. And in such cases, you cannot use the multiplication formula, the multiplication rule. But if your events are independent, as I already said, you just go straight and use your multiplication rule. And that will simplify things sometimes. So, for example, if somebody asks you, what's the probability that I get 4 3 times when rolling 3 dice, you can make a list of all possible outcomes, but each die having 6 sides and having 3 dice in common, you will have 216 outcomes, and I don't think that you will be particularly happy for making a long, boring list of 216 different combinations of dice. But instead of that, you can just take a separate probabilities for having 4 in first roll, having 4 in second roll, and so on, and then multiplying them using the multiplication rule. Still, sometimes sometimes it's still kind of tedious. For example, if you are tossing 10 coins, let's look at that. So if we are tossing 10 coins and we want the probability of 7 coins landing heads up and 3 tails up, even using the multiplication rule and addition rule, you will have a hell lot of a job, because you can have all the different combinations. It's like you can have first 7 be heads and then 3 tails, or you can have head, tail, head, tail, head, tail, head, head. I'm not sure how many symbols are there already. Yeah, okay, looks all right. Or you can have something like 3 tails first and then heads. So there are tons of different combinations. In fact, there are 1,024 different combinations, and even using additional rule and multiplication rule, the job becomes quite hard and quite boring. And we have tools for such cases too, but then we will consider them on our next lesson. I'm not totally sure what day it is. Do any one of you have a schedule at hand? I guess it's either Thursday or Wednesday. So we have classes 2 times a week, and the second class should be either on Thursday or Wednesday. So
we will cover this topic next lesson.
Yeah. So next lesson we will move to this thing. So how to count outcomes without counting them when we have 2 large numbers. So there is a thing called principles of counting, and you might be already familiar with it under a different name, combinatorics. Yeah, so number of arrangements, number of permutations, number of combinations, and so on. So next, on next lessons, we will cover that topic. We will look at it. We will pick apart some examples and maybe do some exercises. Still, I'm not sure which day is it. I will have to check my schedule. Anyway, I guess I will just make either a Canvas announcement or message you all again through the Canvas. But for today,
I have a question.
Yeah, sure.
For example, if we had kind of 3 dices with kind of not 4, 3 parts of 4 numbers, consisting 4 numbers. We had that kind of 2 dices with 2 options of 6 numbers, if you remember. So we had that kind of 36 cells in it. Before that, we've done.
Yep. So you are talking about for example, about this or this.
This one. Yeah, this one.
Okay.
What if we have kind of 4 numbers from the left, 4 numbers from the top one, and 4 numbers from I don't know, from the right side?
Okay, so you
How
have
will this
3 4-sided dice.
Yeah, 3 4-sided dice. Yeah.
You will have 64 different outcomes. It's 4 to the power of 3.
Sure. So this is also gonna be solved in this way, yeah?
Oh, well, yeah, you can do it this way. You can make a list. I'm not sure how you will tackle with it being 3-dimensional, because you have 3 dice and you won't have 2 axes, you will have 3 axes, but there might be some smart ways to put it in 2D way. But yes, you can make a list of all possible outcomes if you want. And if you don't use any additional rules, you will be forced to do it that way, and it will take a lots of a time, and you will be bored to death.
But in any case, we will cover this also, yeah? Next
Yes,
lessons.
we will look at it and we will see how to tackle that.
And are we considering to take any book from the library?
Well, there is a book by Douglas Lind, so let me write
it's
your name
important
here.
to take.
Douglas Lind, and the books, well, let me check the name. Give me a moment. It was either an introduction to statistics or basic statistics. I guess it was basic statistics, but let me check. Yeah, so Douglas Lind, well, in fact, it's not only Douglas Lind. There are three authors, Douglas Lind, William Marshall, and Samuel Watson. And the book is called Basic Statistics for Business and Economics.
So during this term, we'll study from this book, or we're going to study from other books as well.
In fact, you can use any statistics textbook you can find. The topics are more or less the same, and I'm not basing my lessons on one one fixed book. This one is just the one recommended by the university. But if you want, you can use another books. So I myself prefer the book by Selkin, for example. Again, my lessons won't be based solely on this book or any other book, but for reading up, if you want to understand something and so on, Selkin's books is just perfect. It's called Statistics. Oh, sorry. So Statistics for, I'm not sure if it was those or it was people. Well, anyway, I guess you will check. For those who hate statistics. Yeah, that's the name of the book, and that's the textbook. Oh, and quite a good textbook at that. Well, the recommended one is also not bad. I like both of them. There are also a whole range of other authors. Maybe you will want to use a book in Russian or Uzbek. Then you can use the book by Gmurman. There is also an English translation of the textbook by Gmurman. But any of them will be fine. The only thing that will be different in those books is the order. For some reason, these guys start with description of data and then come back to probabilities later in the course, but I find it better to start with probabilities, and so the order of topics is a bit different. But all the topics are there, all of them are explained quite clearly, perfectly, with good examples, both in this and this, and